Hey everyone, today we'll be solving LeetCode problem number 268, missing number. In this problem, we will be given an array of numbers containing n distinct numbers from the range 0 to n, and we have to return the only number in the range that is missing from the array. Okay, so it is given to us that we will be given an array of nums having n elements from the range 0 to n, both inclusively. It means it is going to have n plus 1 numbers because 0 is also included. From 1 to n it is n, 0 is also there, so it is n plus 1 numbers. So from these n plus 1 number we only have n numbers in our array. That is one number is missing and we have to find that number. That's the problem statement. And the constraints given to us is like length of this number array is going from 1 to 10 power 4 and all the numbers are unique. Okay, now let's have a look on the problem example. Here we are given this as a number and this is having n elements, which is 3. So the numbers should be from the range of 0, 1, 2, 3, and we have to return the number that is missing from this range. So this range is starting from 0 and ending till 3, and this array is having 3, 0, 1. So 2 is not present in this numbers array, so we are going to return 2 from this function, from our solution function. Okay, I hope the problem statement is clear to you that from the range of 0 to n we have n numbers and we have to return that one missing number. So the first brute force approach can be like, why don't we just directly sort this array? If I sort this array, it would become 0, 1, 3, and we can directly check from 0 to n. If any element is not matching with the range, we are going to return that element. So the range is 0, 1, 2, 3, and the sorted form is 0, 1, 3. 0, 0 is matching, 1, 1 is matching, 3 and 2 is not matching. It means from this number at this position 2 is missing, so we are going to return true 2 from here. So that was one approach, and in total we are going to discuss 4 approaches for this problem. First one using sorting, second one using hashing, third one using XOR, and fourth one using sum. So in the first approach, what's wrong here? So if we look at the time complexity, first of all we are sorting the whole array, so that is going to take order of n log n. So the overall time complexity is going to be order of n log n. What is the space complexity? We're not using any extra space or the space used in the sorting algorithm. So n log n time is quite high here as compared to the to the problem given to us. So if we directly use the hashing you mean the constraint is from 1 to 10 power 4. This is the n value we can have. So if so it means that we can accumulate all of these value in an array. So what is hashing here? Hashing you mean that the problem statement given to us was 3, 0, 1. What is hashing? The range can be from 0 to n. So if I take an array of size n plus 1, that is going to have indices 0, 1, 2, 3, 4 and so on till n. And in that array of integer, or you can say you can also take an array of boolean, we will keep on storing the state we will see in our given numbers. So if we for the first value is 3, it means 3 is present, so 3 is present. Second value is 0, 0 is also present, 1 is present. Now what we'll do is we'll loop it till n and we will see what element is missing. So from 0, 1, 2, while moving from 0 to 3, at 2 we will see that it is not set and by default the value is false if it is a boolean array. So we will directly get to know that 2 is not present in the list. So here what we did is I did the hashing. I used a hash array to store the state of each element mapped to the index 0, 1, 2, 3. In this example, the range is going from 0 to n. N is 3, so we will take an array of 4 size. And here 0 is present, 1 is present, 3 is present, 2 is not present, so 2 will remain false and we can directly return 2. So here, what is the time and space complexity? If we look at the time, first of all, we took an array and then stored the state whether an element is present or not. So that is order of n. And after that, we checked what element is missing. That is again order of n. Order of n plus order of n. In general, it is order of n. And what is the space complexity? Here we are taking extra space to store the state of to store the hashing. I'm taking extra array. So the extra array will result in the extra space. So time and space is order of n. Before that, in the sorting approach, the time was at order of n log n. So we are directly discarding sorting. We are not going to use it. Hashing is a good approach. Here the time complexity is order of n. But in the problem statement, we are also asked a follow-up question that can you do the solution in order of n time with a constant space? So here we are able to do it in a order of n time, but we are not using constant space. So we are given 3, 0, 1 as our nums, and we have to return the element which is missing from this range 0, 2, 3 both inclusively. So what I can do is I can use the XOR operator, XOR binary operator. What does the XOR operator do? If two elements are same, it is going to return 0. If two elements are not same, it is going to return 1. 1, 1 is also same, so it is going to return 0. So what XOR will do is, if I'm XORing 3 with 3, it is returning 0. 3 with 4 is not a 0, and what I will do is I will XOR 0 and 5. It is going to return me 5. So I will use these operations to make the XOR. So if I make a XOR of 3, 0, 1 with the range, what is the range? The range is 0, 1, 2, 3. If I take combine XOR of this, and then make XOR of those two values. So in conclusion, it is going to cancel out the same values. So this will cancel out this, 2 will cancel out, no, 2 is not going to cancel out, 1 is cancel out this, 0 is already 0. So ultimately it will be left with 2. So what we can do is, first of all, we can take XOR of these values from numbers array, or you can say actual XOR, or you can XOR all the values from the range which is from 0 to n. That is, you can say expected XOR, and then make XOR of these two values. So this is going to be my answer. So I can directly return it. If it is not clear to you, then you can watch it again, or you can move to the fourth approach, which is quite simple. So our nums array is 3, 0, 1, and the range is 0, 1, 2, 3. That is from 0 to n, and I have to return the missing element. So the range is not too large, 10 till 10 to the power of 4. So I can directly take a sum. So if I take a sum of all of these elements in the in the actual range, so that is expected sum, you can say. This is the expected sum, and this is the actual sum. So what is actual sum? Actual sum is 3 plus 1, 4 here. 3 plus 3, which is 6 here. So if I subtract the actual sum from expected sum is 6, actual sum is 4, I will get my answer. Simple. I hope this is the simplest approach to implement, or to understand. This is the range given to us, and we are also given that our elements are in the form of 0 to n range. So take sum of that range and take sum of elements in the nums array, and then do the subtraction, and I will get the answer. So what is the time and space complexity of these two approaches, XOR and sum? So for XOR, I'm taking XOR of our nums array and XOR of our range. So in general, it is order of n for nums, order of n for range. Time is order of n, and what is the space complexity? We are not taking any extra space, so space complexity is order of 1. So we are able to achieve what we were expected in our the follow-up question. If we have a look on the sum example, sum approach, here also we did the like expected sum minus actual sum, and we got the value. The time complexity is order of n, and the space complexity is also no, space complexity is 1, because we are just storing two variables, let's say a and b. So space complexity is constant. So order of n time and constant space. You can implement all of these approaches, or all of these approaches are quite simple. I'm just going to implement any of these, XOR and sum. We are given this nums array which is having elements from 0 to n, but one element is missing. So we can directly check using the sum of actual range and the range we have in the nums array. So first of all, let me capture the n. N is nums.length. And what is our expected sum? Expected sum is 0 plus 1, 2, 3, 4 till n. So from 1 to n, we already know the formula. N into n plus 1 divided by 2. We got the actual expected sum. And what is our actual sum? Actual sum is the sum of all the elements in the nums. Nums actual sum plus equal to I. Now we have the expected sum and the actual sum. Expected sum minus actual sum. If I subtract the actual sum from expected sum, I will get that one element which is missing from our nums array. Yeah, now the implementation is over and sample tests are passing fine. Submitting the problem. It got submitted successfully. It was a pretty simple approach, and you can also try implementing the XOR approach as well and do the hashing as well to revise that hashing concept. Okay, hope you understood the problem. Thank you guys. Bye bye.